Hey, AC, can you put your head up, please? You need to go to the nurse? No? Okay. Sometimes if you let your body language dictate your behavior, you will fall asleep. Don't I know that? I've done that before. Okay. Why complex numbers? If I asked you what the square root of negative 36 is, you guys would tell me? Impossible, right? We've kind of already had this discussion because we've had some no solution answers. The answer to that question is there does not exist a real number, positive or negative, that can be multiplied by itself and result in a negative number. So sometimes when I ask that question, what's the square root of negative 36, someone might real quick, without thinking too hard, just say negative 6. And then we think about it for a moment and we're like, oh yeah, that really would work because negative 6 times negative 6 is positive 36. And then it's not positive 6 because 6 times 6 is positive 36. And you can't have a negative 6 and a positive 6 because then it's not the same number, right? So then it's not a square. So you can't square root it. No, there is no such thing. It's not possible. They're not the same number. I'd rather have $6 in my bank account than negative $6 in my bank account. They are not equal. So this started happening a lot where we would be trying to take square roots of negatives, which we can't do, but we needed that value to keep working. So mathematicians created what we call complex numbers and something called the imaginary unit. So you should write this in your notebook. The imaginary unit is a letter I. Now, I always write my I with a little tail on it so that you can tell it's not like a 1. If it bothers you, I apologize. I love it. And I represents the most basic imaginary value, which is the square root of negative 1, which also doesn't exist, right? Okay? But we're going to say, if it did exist, we'll call it I, imaginary. Okay. So, if I is the square root of negative 1, what's I squared? It's the square root of negative 1 squared, so it's negative 1. Okay.
So would 2I?
No, 2I would be 2I.
Okay.
Yep. It would be 2 imaginary units, 2 square roots of negative 1.
Okay.
But we would call it 2I. We would leave it as 2I. We wouldn't put the square root of a negative number. So like from now on, if you ever get square roots of negative, you should change them to i's. So let's say I had the square root of negative 3. Well, because it's the square root of a negative, we know it's imaginary, so there's going to be an I. Can you do the square root of 3? No, so it's just I square root 3. But what we like about this is, like, if I showed this to someone, we would question what the I is, and the I immediately tells me it's imaginary. Could you, like, think about showing this to an Algebra 1 student, and they might think that's a real answer. They might think that's a number. And we instantly know it's imaginary over on the other side. Maddie.
Why would it? Is it because since I equals negative, the square root of negative,
Uh-huh.
why would you put the I outside?
It's the square root of negative 1 times the square root of 3. And the square root of negative 1 is I. It's not the square root of the square root of negative 1. It's just I. Okay, let's try. What if I gave you the square root of negative 36 like I asked about? It's imaginary, so we're going to have an I. What is the square root of 36? 6I. It's just a regular square root with an I on it. Okay, so let's do the square root of negative 12. Well, it's going to be an imaginary answer, right? So I could say I square root 12. Can you simplify the square root of 12?
Yes.
Yeah, it's the square root of 4 times 3, right? So the 2 comes outside with the I, and then you have the square root of 3. So really the only difference is if you see a square root of a negative, you're going to put an I out front. But you treat the square root just like normal. Like if you can do the square root, do it. If you can't, leave it alone. Square root 3. Okay. So we're going to solve. Did I skip one slide? No, I didn't. Okay, we're going to solve some quadratic equations now. 3x squared plus 1 equals negative 9. Which method would you use to solve? Taking square roots or factoring? Taking square roots, because what do you see? Just one x squared in the equation. No other x exists. Can I get it all by itself? Yeah, I will subtract 1, divide by 3. Okay, so let's do 3x squared equals, it's now negative 10. Divide by 3, this is x squared equals negative 10 over 3. And then we're going to take the square root of both sides, which a couple days ago we had a warm-up where we just said no solution, right? Now we can say what the solution is in imaginary numbers. Okay, so we have x equals plus or minus, because we just square rooted to solve. I, the square root of 10 thirds. Are you okay with me writing it like this? The square root of 10 over the square root of 3. Remember we talked about that rule? Where if it's a fraction underneath, if they're being divided, you can separate them. Okay, what do we have to do with our answer yet? We have to multiply out the radical 3, so it's not underneath the denominator. This is something we're learning, we're getting better at. It's called rationalizing your denominator. Making your denominator a rational number, not an irrational number. So we're going to multiply by the square root of 3 on the bottom and the square root of 3 on top. So we have plus or minus I square root 30 all over 3. You can write it like that. You can write it like this. It's all the same. Because that's like I over 1. It's all in the numerator. It doesn't matter if you put it out in front. If you put it in the numerator, it's getting multiplied. So you're okay. Okay. I'm going to guess I wanted a parenthesis right there. How about this one? 2 times the quantity x plus 1 squared equals negative 16. See if you and your group can work together to get an answer.
Oh, I did minus 1.
Okay, I saw most groups start by dividing by 2, which I would do. You can't distribute 2 and then in parentheses, and remember we've talked about that before with taking square roots. You don't want to do more stuff to x, you want to move the stuff on the other side. And then you get x plus 1 quantity squared equals negative 8, so you got to square root both sides. When you square root to solve, what do you have to add? Plus or minus. Okay. And this is now I square root 8. Can you simplify square root 8? Yeah, it's the square root of 4 times the square root of 2, which is 2 square root 2. So I'm going to call that plus or minus 2I square root 2. If you wrote like I2 square root 2, that's fine. I just, like, you're going to see it written as we progress through the chapter. Like, you would treat it just like a variable. Like, you would call it 3x, not x3. Okay, so you would call it 2I square root 2. And then you still have to do what? Subtract that 1. And remember, this is kind of like that question on the concept check. It goes in front of the plus or minus. So x equals negative 1 plus or minus 2I square root 2. Now, this is a real number. This is an imaginary value. Can you add them together? No, they're not like terms. This one has an I and this one doesn't. This one has a radical and this one doesn't. Can't add them. So you just leave your answer like that.
If that wasn't imaginary, would you still do it like that?
Yes, because it has a radical. But if it was like negative 1 plus or minus 2,
Yeah.
those are both regular real numbers, and you would do negative 1 plus 2, negative 1 minus 2. Okay. Questions? It feels kind of weird, and like right now you're just like, okay, so the answer is imaginary. We don't have a lot more detail about what that actually means, but that's something that you can look at. Now, all complex numbers are written in standard form, so they look like a plus bi. This is something I'm going to work with you on. Like, can you work to try to always put the real part first and the imaginary part second? Because it's our first go-round learning the imaginary unit, some of us might mess that up a couple times, and that's okay. But generally, you want the real part first and the imaginary part second. Okay, and that's called standard form. So in standard form, that's like all mathematicians agree that we're going to write our answers the same way. So we're all going to make our answers look like a plus bi. Now I think you're really going to like my next examples. Because with complex numbers, in addition to solving the equations and getting imaginary answers, you can add and subtract complex numbers. I'm going to go through this kind of fast because I have one more example after this I want to get through. We've got about 5 minutes left. So get on this train, right? Suppose I give you two complex numbers, 3 minus 2i. See how that's written like a plus bi? Get your real part first, 3, your imaginary part second, minus 2i. Okay, and then I want to add 3 plus 2i. Sorry, 4 plus 2i. Check my eyesight. What do you think? How do you think you might be able to add them? Distribution would be multiplication. You don't have to distribute. What could you add together?
You just add the like terms.
Like terms. Thank you. 3 plus 4 is 7. Negative 2i plus 2i cancels out. So you could say 0i, but really the answer is 7. So you could have complex numbers that add to make a real number. Okay. And if you want to, you could write a little note to yourself what Jake said. Combine like terms. That's what you're doing right here. Okay. If you have a subtraction problem, and I'm going to go through this one real quick so I can do multiplication. I would just be really careful. I always change my subtraction to adding the opposite. So I'm going to change this to a plus, which I have to change all the signs of the complex number behind it. So then I can combine my like terms. 8 plus 2 is 10, and I plus 3i is 4i. Okay, so sometimes they add to be a real number, and sometimes they add to be an imaginary number. Okay, last example. Yes?
Were those negatives before?
They were negatives. I added the opposite. Yep. It was minus negative 2 minus 3i. Okay, last example is multiplying. Now we're going to do what Alex said, which is distribute. You just treat I like a variable. So like before, we just combined like terms. Now we're going to distribute. 2i times 5. 10i. Okay. 2i times 3i. 6i squared. Now that's weird. We don't have an I squared before. What did we say? Did anybody write back when we did imaginary unit? What's I squared equal to? Negative 1. I squared equals negative 1. So this is really 10i plus 6 times negative 1. So negative 6 plus 10i. Do you see how that looks like a plus bi, my standard form? Anytime you multiply and get that I squared, it's going to make that number real, but it's going to be the opposite sign of what it was, because it's negative 1. Okay. And so if we did that last example, we would have to work through the whole FOIL, right? 4 times 3 is 12. 4 times 2i is 8i. Negative I times 3 is negative 3i. I'm just treating it like an x at this moment. I've been doing this since Algebra 1. And negative I times positive 2i, that's negative 2i squared. Okay. I can combine my i's. 8 minus 3 is plus 5i. And then I have this minus 2 times I squared, but I squared is negative 1. So do you agree this is really plus 2?
Yeah.
Okay, so this is 14 plus 5i. But see how my answer always goes back to a plus bi in the end? I can always get it there. Okay. So you'll have some mixture of problems on the homework. Some where you're solving and you put the I into your answer. Don't leave me square roots of negatives anymore in your answers. And then you'll have some where you're already given complex numbers and you're doing the operations. Just a reminder, your test retakes for Chapter 1 and 2 are due by next Thursday, so if you haven't talked to me already, make sure you do that. You can now understand this if you've ever seen this before, right? Get it? Hi?
We should all get matching shirts.
We should!